Welcome to your lesson on quadratic models. Quadratics take the form graphically of a shape called a parabola and therefore are a very important model used in our world as gravity makes most objects move like this through space on planet Earth. Okay, so imagine this. We had Oliver practicing his basketball skills. What path will the ball follow? Well, we talked about that. And when somebody's shooting a basketball or on planet Earth, whenever you send something in a trajectory, gravity will cause it to follow this kind of path. That is a parabolic path. All right. If he's standing further from the hoop, we can see this kind of parabola. We know 70 degrees is an ideal shot angle, so as he goes further out, he wants to maintain the 70 degrees that it leaves his hand and enters the basket, so it ends up being a much bigger arc. Alright, but those are all parabolas there. Some people shoot like this though, and then it doesn't go in, it goes off the rim. Okay, the less angle, the worse it is. It's still a parabola though. Okay, let's look at the basketball shot online. We look at this in class as well, but let's take one more look just to see what's happening here. So here's our parabola. And a model for that is this. This is a quadratic model. Anytime we have a highest exponent power of 2, it's a quadratic model. So here we have an equation that has x squared. So that is quadratic. These values, a, b, and c, are called parameters. As we change the parameters, the shape of the parabola or the graph changes. And I can change them as I want here using these sliders I've put in to try to make a parabola that models this shot. And I'm getting closer. Oh, that's a bad arc though. It's not, the angle's too much. Alright, so let me change this value. I'll change the A value a little bit more and maybe I'll get the right arc. Oh, it's tough to get this just right. Something's not working out for me, so I might have to change the B as well. I can't get it to work, but it should work out. It should. I don't know why I'm having so much trouble. The perfect arc for this shot would be, I think I have it revealed here. It would be using this model here. So you can see our A value, our B value, and our C value. And there's a parabola. This parabola has lots of characteristics we should know about. Let's talk about those in just a moment. But here's another example of something moving in a parabolic path. This dolphin has done this incredible jump. And that's a great photo capturing it piece by piece there. Alright, so what we have is it's following a parabolic path. And the function for that is given here. Notice instead of y, we put f of x. That's okay. That's called a function notation. That means the same thing as y. So here we have a function representing that path. It says x represents the horizontal distance in meters. So here's x. And y or f of x will represent the vertical height. That makes sense. This is the meter horizontal distance, and this is the height of the dolphin. How can we find out how far the dolphin jumped? Or how high it jumped? Okay, so two questions. How far did it jump? How high? Well, how high will be right here. If we can just find that point, which is a special point on a parabola, then we will know the height. And then to find how far it jumped, well, if we can find out where it jumps out of the water and where it hit the water again, that distance there along the x-axis is the distance it traveled, right? So here I've put that dolphin jump on Desmos to make a parabola that matches it. So here's the function or parabola it gave us. I entered that function here, and we can see it models that jump very, very well. We see an upper point here of 10.6. That point is called a vertex. This is the x value, so 10 on the x and 6 on the y-axis. So notice when we asked how high did the dolphin jump, we can look at the y value of the vertex, because that tells us it jumped 6 meters up in the air here. The y value, right? Not the x. Okay, and then the other question was how far did it jump? Well, how far did it jump? I mean, we can look at it backwards here because it's going this direction, but it can be the same if you look at it that way. Basically, it started at the point 20, that's an x-intercept, and the other x-intercept is 18.0. So it basically made it from an x value of 2 all the way to an x value of 18. And that distance is 16. 18 minus 2, 16. So it jumped a distance of 16 and a height of 6. And it reached its maximum height of 6 at a distance of 10 horizontally from where it exited the water. Okay, so parabolas tell us a lot about trajectories on planet Earth. Here are some summaries. If you're taking notes for this video, this is the part you should definitely be taking notes on, so grab your notebook now. So quadratic functions are polynomial functions where the highest power of x is 2. So we have, for example, this function, and the highest power of x there is 2. So that's a quadratic function. A cannot be 0. If a was 0, then this x squared would be non-existent, and we would no longer have a quadratic. So that's why a cannot be 0. The values a, b, and c, those three values there, must be, this means real numbers. They are elements of the real number set. So they can be any real number. That means any decimal, fraction, positive, negative number. Alright, so that's our quadratic function. The graph of a quadratic function is always called a parabola. Okay, next. The maximum or minimum point on the graph of a quadratic function is called a vertex. So this point right there that we saw in the dolphin's jump is called a vertex. If the parabola was not going up like this, instead it made a U shape going down, the vertex would be at the bottom, but it would still be a vertex. And it would be the minimum point. This one is the maximum point. Okay, some background for you. Frenchman Nicole Oresme was one of the first mathematicians to consider the concept of functions in the 14th century. The term function, however, was introduced by the German mathematician Gottfried Leibniz in the 17th century, and the notation was coined by Swiss mathematician Leonhard Euler in the 18th century. So math is something that grows over time, and here we can see over centuries the same ideas were looked at with different eyes, and new concepts were added. Okay, let's talk more about parabolas. The x-intercepts are the points where the graph of the parabola cuts the x-axis. So here are two x-intercepts right there and right there. There are two x-intercepts where the parabola intersects the x-axis. They are also called the zeros of the function. Remember that, the zeros, because they are x values when the function or when the y value is 0. See, when on the y-axis, when the y is 0, those are the two x-intercepts. That's why they are called zeros. You can find the x-intercepts using what is called the quadratic formula. If you don't remember that, you should definitely write it down. That will always give you the values of those two x-coordinates. And it uses the three parameters from the quadratic function itself, the a, b, and c values. Okay, some more history. The Shulba Sutra in ancient India and the Bakshali manuscript contained an algebraic formula for solving quadratic equations. So way back when, this is a long time ago, a few thousand years ago, in India, they were solving quadratics using their own formula. Okay, so again, remember, those are called the x-intercepts or the zeros. Okay, last thing we should know is the y-intercept. And the y-intercept can be seen right here. It's where the parabola intersects the y-axis. And that occurs when the x value is 0. And that's what this means. See, in f of x, when we replace the x there with 0, we're saying x is 0. So when we put 0 in for x, and that makes sense, x is 0 there, we get the y-intercept. Okay, so pause if you need to. You need to understand these details, all the vocabulary, and the little formulas it gives you. Okay, now we're going to grab our calculator, because in our course we don't have to worry about analyzing graphs too much. We can rely on our calculator almost all the time. So how do you take a graph from your calculator, a quadratic, and transfer it to paper? There are some important points we need to know here, and then we'll do it together on the calculator. So how do you take that graph and put it on paper? Well, obviously you look at it and you draw it on paper, but there's important things we have to consider. In the IB world, you may be asked to sketch or draw a graph. Okay, so you need to be careful when doing this. When you copy from your calculator onto paper, be careful. Okay, it says when you sketch, it does not need to be as accurate as when you draw. So draw means a very detailed drawing of your graph, but sketch is usually what we'll see as our command term, and it means draw a sketch. It's a rough sketch, but it must include some things. So the sketch should include the general shape accurately. So you should do your best to draw a good curve and not make this triangular or something like that. It should also label the coordinates of any axis intercepts. So notice here the x-intercepts are labeled and the y-intercept is labeled. And remember, the x-intercepts occur when y is 0, so we see 0 there for both of those. And the y-intercept occurs when x is 0, so we see 0 there. So make sure you label those. And it says also label the coordinates of any vertices. So here's our vertex of the parabola, it's labeled. So all those 4 key points are labeled, and that is considered now a good sketch. You do not need to label the axis point by point. Final thing you should know here also, the x values of a graph are called the domain, and the y values are called the range. So the x values that are possible in this parabola are the domain, and the range is all the possible y values. You need to know how to work with those. We'll look at that soon. Okay, so let's try this example. You're given this graph here. Okay, so let's look at how we do this on our calculator. We are given a quadratic function here. We need to sketch it on paper. To do that, we need to begin by sketching it on our calculator and getting the important points. So let's grab our calculator. Here it is. Okay, so with our calculator, you go to y equals anytime you want to graph, and you enter the function. X is here. This can be used for raising to a power to get the exponent, and this first negative must be using this negative button here. So enter your equation and hit graph. There's the graph it gives me of the parabola. Maybe your window was set differently, so maybe you don't see it exactly like this. If you ever want to see the basic graphing window, which is 10 units in every direction, we go to zoom, and number 6 is zoom standard. So I'm going to press that now. And that gives me my standard 10 by 10 by 10 window here, and again you will see the same parabola I had. The problem, however, is our parabola that we graphed here is cut off a little bit. So I'm going to extend, I need to see higher on the y-axis, I need to see lower on the y-axis to see the y-intercept, and I need to see more along the x-axis to see where the parabola intercepts here. So I'm going to go to window, and I'm going to set some values here. So x max needs to be more. I didn't see far enough, so there's 15 units there. The y min was not low enough also because I was cutting off where the y-intercept is, so I'm going to put negative 20. The y max was not high enough. I didn't see the vertex, so I'm changing that to 15. So now I'm going to see a little bit further in each direction. See, I can see further here, further down here, and so on. Now I can see the full parabola. Great. Now how do we find the points? How do we find the x-intercepts? Let's begin with those. They are right here. So one way to do that is to hit trace. Trace puts a cursor on your graph and gives you the coordinates as you move it. However, we can't quite find the intercepts. See, here it's a little bit off. So I'm going to do second calc instead, which is above trace. Remember that x-intercepts are called zeros, so number 2 there is 0. I'm going to press 2. Now I can calculate the zeros of the x-intercepts. It's always going to ask you left bound and then right bound. Left bound means go to the left of the point you're looking for. So I'm looking for that point, I went to the left of it. Enter. Now right bound, now go to the right of it. I'm to the right of it now. Think of it like you're making a box around it. If I was making a box, I am now to the right of the point I want. Okay, enter. And finally guess. Guess means it's asking you, the calculator is asking you, tell me roughly where that intercept is. So I kind of move the cursor close to it, enter. And it tells me the x-intercept is at 3, 0. Now try the same process and find the other x-intercept right here. Okay, hopefully you found it, and it's at 12, 0. Now another way to find those 2 points is to, well, I'll show you in a moment. We also need the y-intercept. Okay, it's going to be over here. One way to find that is second calc again, and we can do value, number 1. And we're going to say, well, at the y-intercept, the x value is 0. So I'm going to put an x value of 0 in and press enter. And it tells me, oh, when x is 0, y is negative 18. So it told me the y-intercept. So now I have the y-intercept and the 2 x-intercepts. So the other way to find those, by the way, is to do second and table. So instead of graph, table. And the table shows you all these values. And there's our first point. See, x is 0, y is negative 18. That's our y-intercepts. And then you follow down. When x is 3, y is 0. That's one of the x-intercepts. And if you went further down, you would find 12, 0, also the other x-intercept. Alright, so back to the graph. Now we need the vertex. To find the vertex, I'm going to put second calc again. And we can see maximum. We know the vertex is a maximum for this one, so I'm going to press 4. It's doing the same left bound, right bound thing for me here. So I'm to the left of my vertex, definitely. Enter. I'm going to go to the right of my vertex, just a little bit beyond. Enter, and then guess, bring it back to where I think the vertex is, roughly right there. Enter. It tells me my vertex is this point, 7.5, 10.125. Great. So check your work here. Make sure you draw a sketch on paper. Check here. Now what's the domain and range? Okay, here's the domain. Domain means, this means all real numbers. X can be any real number. This parabola goes forever here, forever here. It can be any real number. The range is the y values this parabola can be. Well, the parabola can be any negative y value all the way down, but it ends right here. So it only goes as high as that point. So the range is y values less than that 10.125. One last point. Please read this and try this problem. The vertex is just the average between, right? There's the answer. Great work.